So the first one I did was the inner. I can't remember the part number. 468-12 enter, I think.
Okay.
But you can see the. Try to get the glare off of there. See if I can.
Yeah, looks good. Back up a little bit.
I was trying to get it a little bit closer up on the hole, but
Yeah, it does look nice. Did you guys receive the example that I sent as well to kind of compare?
yeah. So one thing that, let me find that. I just had it out. I put it over here. So I got this example here. So a couple of questions that I wanted to ask on this. Now you guys are punching this out. Is that right?
Yep.
So it might have been you. It was in an email chain. Something about you punch them out and then it has to go through another process to get burrs off. And so can you kind of just explain what that process is and how it flows?
So the one thing you might have noticed is this width of C channel here has 3 holes compared to the 4 holes that you have on the one to your left.
Yeah.
So that's our connector pattern. And as the C channel gets wider, that pattern changes from 3 to 4.
Okay.
So that is just 2 separate dies that punch those 3 holes all at the same time. And it actually shears the part and punches the other end. So it's actually 6 or 8 punches and a shear. And it splits the piece and starts the next piece because these come in 20-foot lengths.
Okay.
Then it goes down to the next step where they measure out those individual 1-inch holes and punch them one at a time with wherever their Sharpie mark is. And it's a pretty old-fashioned way of doing things, but that's how everything's been running since, and that's what they know. So
once, I'm sorry, go ahead.
Yeah, the whole process is labor intensive, and there's several different pieces of machinery involved. So we wanted to kind of reduce that and streamline it a little quicker, faster, try to pull some labor out if we can. So now that that's kind of understood, the quality isn't super important. It's more of reducing that labor
Right.
and allowing the shop floor to flow through, I guess, less routing steps, or however you want to call that.
Yeah, be able to complete a part in a single setup.
Yeah. That notch that you see on the side there, that was an example of the only other feature that we'll have. That angle on the slot will change, but it won't be on a high volume of parts, and that's a third press that we have. And the reason for that notch is so that the part can bend and reduce from, let's say, 24 inches down to 12 inches. I sent some paperwork in the email or in the package there. You should be able to see that pretty clearly. It's just, I'm not sure if that's achievable with an articulating or a horizontal mill, but just wanted to include that in the scope.
So would it still be possible, like let's say you bought this machine, could you still run these through, let's say the shear to get them to length, and then also for the notch, or like what all features are you wanting to do on the machine?
Anything you see there. So the connector holes in both different patterns, the 3 and the 4, that 1-inch hole, and the notch on the side. So that notch won't ever get smaller. I think the smallest is the 90-degree notch, but it could grow to 135 or so.
So you're wanting to put the notch on the machine as well?
Yeah, if possible. I know it's going to require a different set of tooling.
Yeah.
That would.
We'd probably have to do that with like a special tool holder to hold something horizontal.
Yeah, and that's and we understand that's going to jump numbers a little bit. But if we're going to attack this project, we wanted to include everything and kind of weed our way out as we see that it's more complicated.
And I can tell you on that end, it ends up being there's a hard cost for the actual holder itself, and then there's also some programming that we have to do because that tool holder wouldn't fit inside the carousel for the machine.
Okay.
And so we end up having to use our favorite word of this time. We'll have to quarantine off a portion of the bed to put a tool holder on the bed where the machine can go over and pick that up. It's pretty straightforward. It just takes some time to be able to say this is the zone, and then telling the machine this is the path that you have to take in order to pick it up.
Sure.
Right. So straight back here is behind that little door. I don't know if you can see the door, but that's the tool carousel back there. So essentially what Joe's saying is you would have, if you can see my finger, you'd have like a tool holder that's bolted to the table somewhere over here that it could drop that tool off instead of putting it back in the tool carousel.
Okay. Yeah, that would be fine. I don't see us. The bed's pretty large. I know there's at least 3 lanes, right? 3 different.
On a C series, it's got three T slots on it. And I can send over video after this of the horizontal tool holder and like how we fixture things on the bed. I've got a handful of things I can shoot over to you.
Okay.
Yeah. So
if we had to dedicate a piece of the bed to that, that wouldn't be a problem at all.
Yeah. So I wanted to kind of showcase, how I did this. Obviously when you're running demos, that it's just a kind of a one-off deal.
Yeah.
The setup is not going to be perfect.
Yep.
So I kind of had to figure something out just to make it work for these parts. But what I wanted to kind of show you, so here's how I have it set up here, to where essentially the legs are going up.
Okay.
The reason why I told Joe I wanted to make this all is this is not how I would run this. If I were you guys, what I would do is essentially create I'm going to flip this part over. Create kind of like a fixture plate, more or less. But essentially, you would want support up under here. So I would put the legs down.
Okay.
Have support up under here. So I would just take a big aluminum block and mill the sides, so you're going to put a shoulder on it. So essentially you would have material here to where you could drill and tap holes to put, let's say, these toe clamps right here.
Yep.
You put toe clamps along the side, but then have your support up underneath the part, and essentially the part would just fit snugly right over top of that piece. And then you got different sizes, but it looked like there was really only 2 different sizes as far as the distance between the inside legs.
We actually have 4. I may have only supplied you with 2.
Okay. Yeah, it looked like I measured the parts that are here, and it looked like there was only 2 different dimensions.
Yeah, so we have 3 1/4, 4 1/4, 5 1/4, and 6 1/4. Or
okay.
Sorry, 4, 5, 6, and 7 1/4.
Okay.
I think I may have given you 7 1/4 to show you the largest.
Yeah, I think I got 7. I think the other one was probably whatever this one is.
Okay.
5.
4,
but
5,
yeah. Essentially, that's what I would do to give you the most support is fit this plate right over something where you have support up underneath here. Because I threw this thing in a vise just to see what it would do. Just set it down on the floor, and I barely snugged that thing up, and you could just see it bow. The walls being really thin, you got to kind of get creative when it comes to fixturing.
Sure.
Hence why I've got this massive fixture plate on here.
Okay. Yeah, I understand the fixturing can only improve from here. I didn't expect you guys to. I mean, this is pretty.
I drilled some holes. If you can see these pins right here, they're kind of stuck in there from coolant. But so I'm using this one as a locating pin.
Okay.
So I'm butting everything up to this pin, and then I've got pins back here.
Alignment or keep that level, yeah.
Yep,
okay.
Just to keep it straight. So, I mean, that's what I did here. You could, do something similar. So here you can see I'm flush to the left and then just push it back.
Yep.
I mean, you could do something similar, but the biggest thing is having the support up underneath there somehow.
Okay, it's good to know.
We should probably talk about the chamfering portion of it that you were doing as well. With
okay, yeah. So I ran I'm going to try to get this plate up so you can try to see the chamfer. I don't know if you can see the chamfer around that hole. It's a little bit shinier.
Yep.
So, the part that you sent in, the example, I could tell which way it was punched because on the bottom side, the burrs are sticking up quite a bit. So what I did on this part was after I drilled all the holes, I came back with a chamfer mill and just went around the hole to take that burr off. But that fixture plate that I'm talking about, if you were to run the program without a part on there and essentially drill out bigger holes on where those hole locations would be, you would give yourself some room up underneath the part at that hole location. So essentially, like this 1-inch hole here, if you were to take, let's say, an 1.25 inch drill and drill into your fixture plate where that hole would be, which here you can kind of see where I had drilled on the fixture plate.
Okay.
If you were to drill that at a bigger diameter, what I would do is get a double-ended chamfer mill. So what that allows you to do is you can chamfer the top of the hole and then take that tool, go down inside the hole, and do another circular interpolation to deburr the bottom side of the hole.
Okay.
So that by doing that, as soon as this part was finished, you wouldn't have to mess with it. Which I don't know if you guys do any, deburring or sanding or anything.
It's more of just like a feeling process. If they think something needs to be touched up, they'll hit it with a hand file. But it's not 100%. It's just where it's needed.
Right.
And you can see kind of what we're putting out there to begin with. So
and so what I did on this one was, I don't have the double-ended chamfer mill here. So I just used one of our regular 1/4 inch chamfers, and I chamfered all the holes. And then when I took it off, the back side, I don't know if you can kind of see the chamfer there. We have a chamfer bit that we threw in I can throw in a hand drill. And I just hit the smaller holes with a hand drill and then used a deburring knife on the big hole.
Okay.
So, but, to try to get as little manual work after the part is done, the better. That's why I would suggest doing, the double-ended chamfer mill to just go down inside the hole, circular interpolate the bottom of the hole to get that burr off.
Okay.
The nice part about doing something like that is it even alleviates somebody even having to look at it and make a judgment call. It's just part of the process.
Right. Yeah. Were you guys able to saw it to length or cut it to length at all?
Yeah.
I sent those pieces oversized so that could be included in the test.
Okay, so I did not program it that way.
Okay.
I know I was actually working from home when the material was sent in. So I didn't actually really see the parts until yesterday.
Okay.
So I had already had the program part of it finished out with, just drilling and chamfering the holes. So, after we we can end this call and I can change the program for the rest of these parts to go ahead and do that.
Yeah, it may be tricky with the uprights. So I'd be interested to see, how
Yeah, and that's kind of why I asked if what all you were gonna try to do on this machine, because I don't know if it's finish quality or what, but the shearing process to get them to length would probably be a little bit faster.
Okay.
And with this wall being so thin, you're only going to be able to get so many clamps on this thing and hold it, so rigid.
Yeah.
But with those walls being thin, it's doable. It's just, it'll probably rattle. You'll get some vibration that might affect the. I don't know how tight your tolerances are on the overall length. But if you get some of that vibration in there, it might affect that a little bit.
Sure. Yeah, the tolerance is definitely pretty open. The connector holes are the only area of concern, but again, there's a ton of clearance in there.
Okay.
But you can see how it's uneven on the left and the right side.
Yeah, I noticed that when.
Yeah, so I'd imagine that's where your cut would be.
Okay.
Other than that, I kind of mocked up briefly every single combination we have, and it's somewhere in the 250 range, 230 range. So from that, I laid them all out, and I tried to see where the cut would be from a 20-foot piece, and I identified some gaps where we could put dedicated fixturing. But now that we have 3 different lanes, we could break that up even further and utilize some more areas or gaps of dedicated clamping, so that no matter what combination we put in there, we'll never run into a clamp with our end mill.
Right.
That's perfect.
If we flip this upside down, we'll be able to clamp on the top, on the opposite side of where the 1-inch holes are.
Okay.
Right? Is that
over here?
Yeah, or we could also squeeze it. And again, we wouldn't run into the clamping mechanism, depending on how wide the clamp is.
Right. Yeah. So actually, now that I'm thinking about this, because like I said, I didn't know what all you were going to try to do on these parts. If you want to cut them to length, I can see how well this cuts with the fixturing that I have. So with the legs up, and probably throw in another clamp. So the biggest thing is going to be, making sure that wherever you are going to cut it off, that you have a clamp close by. So now that I'm thinking about this, we might be able to take that full sheet, and I don't know how many of these you need to make, but if you have that full piece up there, you might be able to essentially drill all the holes and then cut them off with the entire piece up there.
Yeah, so the idea would be put in a 20-foot length and say we need 6 or 12 on the order. We hit those pieces, and then if the scrap or the fall off at the end is large enough to make a case for keeping, then we would keep it on the side, and they would try to utilize as possible. I know that's going to get a little sticky with the programming, so it's going to be something that we have to evaluate on our end.
Do you guys use like some sort of a CAM software for any other machines?
We don't, but I have in the past. I've used CAD/CAM interface with Inventor on machines, and I understand the basics and how to go from a 3D model to a file or whatever they call it, the G-code file.
Right.
But as far as really digging in, I don't have too much experience.
No one on that end. One of the nice things that we have with the purchase of a machine, you get basically like a 3-day class.
Okay.
Aaron is one of our instructors, and so they can take you from basic knowledge to being able to run this machine so that when it hits your floor, you're ready to go.
Sure.
And then when we do our installations, So we'll actually have one of our guys out there doing the install, and we try to leave some extra time at the end of it so that it's like, all right, you want to load your tools in and I'll help you out with that, and you want to get a part ready, you know, they can help you do a lot of stuff. We try to make it as warm of a handoff as we can.
Okay. Yeah, that would definitely be something we're interested in. In a perfect world, we would want to have the program set, know what it's doing, and then I don't know if it's possible, but for the operator to put in the number of pieces, and then the program kind of hits that linear pattern. If that's possible, you know, cut 6 of these, it'll know to copy paste that program 6 times down the 20-foot length.
Yeah, you're getting a little trickier. It's not impossible.
Yeah, I know it'll be serious work, but
and the biggest thing is, you know, whoever your operators are, if they're not necessarily machinists and they don't, you know, fully understand the M and G code side of things, it can get really confusing. You know, there would have to be a level of understanding of, you know, what the code looks like, what the codes mean, what the machine's going to do before they even run the part. Because, you know, obviously mistakes happen, but you want to try to catch those mistakes before, you know, you start poking holes in the part. So like I said, it's not impossible. You're getting a little bit trickier by doing that. But like I said, it's more or less on the operator if they have that level of understanding. So, and you know, like Joe said with the training, what I would suggest is whoever would be involved with this machine, as far as operating or yourself programming, you know, whatever, bring them.
Yeah.
You know, whoever would be, you know, hands-on with this machine should probably be a part of that training.
Okay. Yeah, the last thing I want to do is be spending 90% of my day on the floor fixing problems.
Right.
So
right.
I'd imagine we want somebody to run with this.
Now, honestly, what might be, I'm trying to think the easiest way to go about that. You know, if you have a 20-foot piece in your inventor file, it might almost be easier for you to, you know, draw up the different parts, I guess, along that piece, because it's a lot easier for, in my opinion anyway. I use Mastercam, and it would be a lot easier for me to click on the features in Mastercam and just post it than it would be for me to try to figure out how many parts I need, copy and paste it in the program, make sure my program matches up. And, you know, for me, it's a lot easier to just click the features and go.
Yeah.
You know, so if you've got, you know, an odd number of parts that you want to try to get off of that 20-foot section, it might almost be easier to just, you know, draw that up in your inventor file and program it. But
yeah, so the issue there is that we don't carry material on hand, so we're made to order plant, kind of like a job shop. And
gotcha.
so running these and keeping an inventory isn't how we're doing things currently. I'm not saying it can't be done, but again, it's going to have to be on our end, something we evaluate.
Okay.
Because right now there's no programming, so they can punch 10 parts, they can punch 20 parts, and they have control over the material and what's left of it, what turns into scrap. So
right.
A lot of we're trying to evaluate the efficiency versus the troubles and the upgrades in the general labor that we're going to have to include in this. One other thing to mention on when you said to drill that 1.25 inch hole into the base of the fixture, that's going to start to look like Swiss cheese, as you can imagine, with all the different combinations.
Yep.
So,
well, and I'll be honest, when I finished, let me turn back on the part here. So when I finished this part, you know, like I said, I chamfered the top.
Yeah.
You know, it took me, you know, if I had all the tools, you know, right here, I had to go find them. the drill and the handy burr tool. But you know, if I had them right here with me to deburr the backside of this, it would only take me probably 45 seconds.
Yeah.
You know, I had the chamfer bit and drill. I hit these holes, you know, the smaller holes real quick, and then I just took a handy burring tool and went around the big holes. So I mean, you know, if that's something that you're not wanting to get into, like you said, with turning your fixture into Swiss cheese, totally understandable. And it didn't take me long to do it. I was just more or less trying to, you know, give an idea of how to do it without having your guys have to do that on every part. But, you know, I don't know if time is an issue for you guys.
Not so much. I mean, we would like to improve our lead times, but that's not really the focus of the project. It's more pulling labor out.
Right.
So I guess we would be a little more concerned with the finish on the end of the cut, that shear.
Yep.
Versus the holes, because that's where you would see somebody collide with one of those corners and really get a razor sharp burr. Yeah, exactly right.
Which I noticed was kind of rough.
Yeah, well, I cut those on a bandsaw.
Oh, okay.
So I kind of just tried to throw something together for you guys without slowing down production.
Yeah, no, that's fine.
So this is good though. Is there any kind of video, or could you run some video of the machine doing the work?
Yeah, so this part that I ran yesterday, I had a GoPro up on the spindle, and then I also had a phone behind me on a tripod taking video. So Isaac took that. He's going to try to kind of merge those videos together, and he'll get that sent over to you.
Awesome.
Joe, I know I told you I would run another part, but now after learning that, you know, we want to try to cut this off.
Yeah.
I would rather not waste time, and no, I need to program that.
I think we'd rather than have us use more material. I think we'd rather be able to see kind of everything all at once.
Right.
And like I said, I can share over the video of the horizontal tool holder. We've got some good video of it slotting on some square tube that'll work pretty well, as well as like what that looks like when you're when we go to house that. So I think that'll be the only thing that I would ask Aaron. So if he was to fixture this the way that you're saying, with the with it kind of tented rather than it laying flat. So if it was flipped over, would you then recommend to have notches in the, I mean, if he's going to go and do that tent or that angle and horizontally mill that out, so would you just have would you have your fixture plate cut out underneath that?
Well, now that, and unfortunately, like, so this is another thing that I didn't think about on the fixturing. I will have a better suggestion after I learn how well this cuts the way I have it fixtured with the legs going up.
Okay.
Because if it cuts well, or good enough, what I would honestly suggest would be to, so there's we have a spot drill that's at a 45, and if the end mill can cut okay on the end, we might be able to take that insert.
I got you. Yep.
And then just go this way with it. Which I honestly hope it'll work out that way, because that would be
a huge saver.
Oh yeah, getting away from that 90-degree head.
Yep.
Would be huge. So
and not having to corn off a portion of the bed, and not having to make the additional purchase and all that stuff. Yeah.
Yeah. So I'm gonna add a couple more clamp locations on my fixture plate here, and then I'll program to shear this thing off, and then I'll even try to program this notch right here.
Okay, awesome.
So
Good work, you
we'll
guys.
see what we can.
Great so far. It's just going to be a lot of those little logistical issues on our end, trying to see if we can restructure the labor in our department and get somebody that's a little more equipped to handle this type of process.
Yeah, so Nolan, one of the other things that I can share with you real quick, we have a pretty nice system set up so that as we're doing a handoff with a machine, it isn't something where we sell it to you and then we're like, all right, good luck. We've got all kinds of different things. We've got a program called FlexCare because we use Flex with everything that we do, because it's all about adapting and being resilient and all that kind of stuff. But the idea being, if you guys aren't ready to like take this machine and run with it, you get these people on our staff like Aaron. And there's a monthly service fee involved with it and all that. But the idea is, if you don't have people who are 100% ready to run with this, we can absolutely help out.
Okay.
And it's doing things like this where you know, instead you're holding the camera, looking at the cart and saying, hey, can you help me out with this? What should I do here? And we've got Aaron, we've got Chuck, that are just great at programming parts to figure out the best way to go about it. We've got our software engineer, the actual controller on the machine, we made it.
Okay.
It's not something where we hired, you know, somebody else to come up with this program. This is our system that we've developed.
Cool. So you know the ins and outs, you can adjust when you need to.
You know the ins and outs, and when you need to have something specifically done on it, don't get me wrong. It's not to say that you can ask us to customize your software and we'll do that for you. No questions asked. But we have the ability to go through and make adjustments. Like I said, so if there's a custom tool holder that needs put on the machine or something like that, we can do that stuff for you.
Cool.
And no, just so we know, I mean, is everything still on track as far as the purchase possibly this year of this machine?
So everything's kind of been pushed back due to the current situation.
Sure.
I know there's just no corporate spending at all right now, but they're still telling us to follow up on the projects and pursue. Yes. From what I've heard from the CEO, there's no mulligans even with all this, so he's expecting results. And I know our supervisors are going to start getting aggressive, but until we have I mean, regardless of the company's decision, we want to have a concrete solution in place before we pull any triggers.
Sure.
Yeah.
If you ask me, it's a little less of whether or not we're going to spend the money and a little bit more of whether or not we can make the argument for these, you know, like the machinist and having this kind of be an all-around upgrade rather than taking out labor and then having me more involved, or having, you know, we have to kind of look at the whole scope. But I'll be honest with you guys, I think this is kind of in the lead right now as far as our who we've been talking with, and who both myself and my supervisor have been most comfortable with. So you got that going for you.
Excellent.
We looked at the water jet a little bit and kind of ruled that out. We weren't comfortable with everything that came along with that. So but yeah, we've been liking what we've seen so far, and what you guys have shown me today and the presentation that sounds like it's coming. Been pretty helpful, and looking forward to seeing the video. So.
Well, and I know that the video that he got over to Isaac, I know. So Isaac is our video guy. He's the one that typically shoots everything, edits everything down. He just bought a house that he's moving into today, so he's gonna be off for, I think does he come back tomorrow, Aaron?
He was actually in this morning.
What a guy.
That's right.
So we'll get him cracking on that here pretty soon. I know that he's got to shoot a couple live videos today that they're going to be posting on YouTube for some different things. But Yeah, we'll get that taken care of. And then the other thing is we'll just make sure to get him involved when Aaron's running the part to cut the ends and to do that angle in the middle of the plate and everything to make sure that you guys can see everything.
Okay. Would you be able to send the parts that were cut back eventually so we can?
Oh yeah, absolutely.
I was just about to make sure that you wanted us to do that. Yeah.
Yeah, if you didn't cut any, we don't have to send all of them, but just for the ones that you did cut. I don't know when I'll be back in. I was in on Friday for 4 hours to just to check on things at the site, but I can be there on Fridays. We shut down production, so there's only a few heads in the office, and
Yep.
we go in. So if that lines up for next Friday or the following, however it works out, we can still receive packages.
Yep.
So.
And I think you sent over, I believe, 5 or 6 different parts. I'm trying to look over here, but I only have models for 4 of them.
Okay.
6, yeah. You sent 6 parts, and then, like I said, I got models for 4 of them. So I'll definitely make sure that we get those 4 cut. But yeah, you'll probably get 2 blanks back.
Okay.
Because I don't have models for it.
If they're the same, it might be a left and a right.
Oh, okay.
So how our parts work, we have the outer radius, which would be larger, and the inner would be smaller, obviously.
Okay, yep.
The parts that are the same are straight lengths that kind of notch down, which is why we have that cutout on the sides. It's
Right,
reduced. So it goes from 36 notches down to 24. So that's going to be the same length on either side.
Okay.
You'll see those represented by ST, which stands for straight reducer.
Okay.
In the middle of that part. I can send you some literature on that too if it's not clear.
I think there was a packet of papers inside the box there with the parts. I kind of had an idea of how it worked.
Okay.
I didn't think about the left and right,
Yeah.
So
if you don't get to all of them, that's fine. I mean, I just kind of wanted to give you guys something that represented everything. If I didn't want to send you something too large, so I think I stopped around 40 inches or so with the largest piece. And then I tried to get something a little smaller, something with notches. So.
Yeah, no, that works. I'll go back in and, like I said, I'll program to cut this thing to length, and then I'll work on cutting that notch, and we'll see how well it works with the setup that I have. And then, like I said, I'll have a better idea of the best way to go about it after I see how it works the way I have it.
Okay. Great.
So.
Good deal.
There you go.
All right. Any other questions? Anything else that we can answer for you?
Not at this time. I have a one-on-one with my boss later, so this is aligning pretty well with that. I'll make sure we touch on this.
Excellent.
All right, well, I appreciate something on Nolan, especially on short notice.
Yeah, no problem. Thanks for setting us up.
Yeah, and I mean, this is something where, if he has any questions or if he wants to see something, I mean, however we can support you guys, I mean, that's the goal here.
Sure.
We want to make sure, kind of like what you said, no mulligans. We want to make sure that you guys know exactly what you're getting, that you're comfortable with everything, that you're confident with all of it. So I mean, we're an open book. We'll tell you every little thing that we can. One of the things that I'll make mention of is that let's say that you guys said, hey, we want to purchase this thing today.
Mm-hmm.
I would not be able to give you a delivery date.
Yeah, I would imagine.
So our builder is in Spain, and then the machines come over as a skeleton, and we build them out. So Aaron, can you pan down the shop real quick?
Yep. Let me switch
You've
my
got
camera here.
machines that are partially assembled and all these different things, but we haven't put our controller on them and all that.
Okay.
He's actually walking past our new beam line that we just got in. So it's one of those things where, not knowing what's going on over in Spain right now and how quickly they're going to be opened up, I wouldn't be able to tell you that. And so we want to make sure that we're as transparent as possible with everything going on, so you guys have a clear expectation of when we actually be able to put a machine in your shop.
All right.
So just as we progress, I'll make sure that you stay informed with that, or I'll be relaying everything through Devin.
Okay.
Yeah, that's more like what your machine would look like. That 2 foot wide cantilever setup.
Mm-hmm.
That right hand side where the bigger portion of the red box is, that's where the tool changer is.
Okay.
But you'd get this big 22-inch display, touch screen, and all that stuff with the rail that runs down it.
Okay.
Aaron, can you show me the proximity scanner real quick?
Yeah.
Is this in Ohio?
Yes. Yeah, we're right between Dayton and Toledo. That's the proximity. Yeah. So it's just a laser scanner to make sure that nobody's within proximity, nobody's going to get hit.
Okay. Yeah, that was a big piece for us. I brought that to our safety coordinator to be able to utilize the side of the bed that's not being operated on, and she gave us the green light, so that's not an issue for us anymore.
Well, and
so here's the back side. There is a light curtain here on the back side. That way you don't have anybody that's...
I think he means left and... Aaron, he's talking about like left and right. If they're operating on the right side of the bed, they can...
No, I know.
Yeah.
I know. I just, somebody to try to come up behind the machine, that's secure as well with the light barrier.
And the nice part about it is that you don't bail on the program if somebody breaks the laser on the front side. What it does is that if they're within a certain range, it'll slow down.
Right.
And kind of notify, like, hey, you're in the laser. And then when they get really close to it, that's what will shut down the program to make sure that nobody's getting hit.
Yeah, and I think you mentioned we can control that X distance and X speed, right? The slow down speed.
Yep.
Okay. Yeah, I was hoping to get in there to visit you guys.
I know.
I was hoping Ohio for some other training. That would have lined up perfectly.
Next time.
I thought I was going on that trip until like 3 days before. So.
Yeah. No, like I said, that we can still make things work out. We're happy to do these, live videos and bring stuff right into your house. So
yeah, this is a great alternative.
All right.
We appreciate it, Nolan. Thank you.
Yeah, thanks a lot. Appreciate it. Have a good one.
Take it easy.
Yeah, we'll see you guys.
Be safe. Be well.
You too.
Thanks, Aaron.
You happy?